Hey everyone, welcome once again. I'm palfun-foslup. I'm with Plum Corporation. You may have seen me yesterday in the core developer Q&A also. Today I want to talk a little bit about two new Eyre features that I added recently. And during yesterday's Q&A, someone asked the question to the panel of what our least favorite part of the system was. My answer was Eyre, actually. I have kind of a strange love-hate relationship with the thing. It's, I like it. It's good that we have it. Because, like certainly in the times that we live in, and certainly at the current stage of Urbit development, asking like, can I have an HTTP server? Like that's a perfectly reasonable question. And the answer is obviously going to be yes. Because you need your Urbit to be accessible by things that are not Urbit. HTTP is a very natural protocol for that, and it lets your Urbit serve its own interfaces to web browser clients. And so you probably know that that's how nearly all of the Urbit application interfaces are served today. And so clearly it's a very, very useful thing to have around. But it's also this giant Earth protocol, HTTP, and with that come all the traditional concerns of like Earth software in general. Like this thing is never going to freeze. We're going to have to keep updating this for compatibility. We have to account for all the different like security considerations that this doesn't solve for inherently, and especially in the browser context. We're going to need to rope in additional considerations that the browser pushes on us also. And so you're always, like when you're working on Eyre, you're always walking this tightrope between, accounting for every little thing, like exposing every little part of the protocol and exploding Eyre in scope, pushing it full of functionality that traditional web servers also provide. The balance between that versus saying, no, we're like only doing the bare bones thing, and anything more fancier is up to the individual application developers. I think a decent heuristic, or at least one of a toolbox of heuristics for making those trade-offs correctly, is thinking about what you can do to make the Earth protocol more Urbity. And so usually the way that manifests is in developer-facing affordances. The two features I added that I'll be talking about today, I think, are good examples of that kind of like taking the existing HTTP request model and making it more Urbity, making it easier to work with within Arvo's context. And so before we talk about these things in detail, I want to give a little demonstration of what I've implemented. So I'm going to try sharing my screen here. Let's see. There we go. So you'll see we're on a very real page of Hacker News. This was today actually, and at the very top, clearly we have a link to an Urbit improvement proposal. Oh, how curious! Let's see what that's all about. We can see we're on hoster.com. We'll go ahead and assume that this is very legitimate and actually served by the host or star. It's a cooler blog, and there's some blog post here, right? This is about UIP00X. This work actually predates the UIP system, so there's no official number for it. But we'll see right away that there's 2 comments on this thing, actually. And so if we click that, let's go down and see what that's about. This comment, bin of hoster, was first, clearly. And the Galaxy has already taken note of this and will, bring it to the higher ups for roundtable discussion. But above the input form here, we see something interesting. It says we're authenticated as rocknep hoster, shorthand for some comment name. That's interesting. We're just a Hacker News visitor. We don't, maybe we don't know what Urbit is, but it's, saying we are someone already. And so, let's try this out. Can we put a comment? And there, as that thing we're supposedly authenticated as, we're putting comments onto this blog post. Now, okay, I am actually not a random Hacker News user. I do have an Urbit. And so, not you, that is indeed not me. I own a star, actually. I own Sample. And so, let's try logging in as Sample. It brings us to a login page on hoster.com where the eauth section is pre-selected. It says it will be redirected to my own web interface afterwards to authorize this login. So let's try that out. I can put in my own Urbit ID here and click continue. It has redirected me to sample.net on port 8080, which is where I know my Urbit interface lives because I've used it there before. It presents us with a little dialogue like, hey, you're a Sample, that is correct. I'm trying to log into Hoster. Well, okay, that matches. That matches what I was trying to do, what I was expecting. So we can go ahead and approve this. That's it. It redirects us back to Hoster, to the blog post we were just viewing. So let's look at the comments again. 3 comments now, and we're authenticated as Sample. Submit. And Sample says, this seems cool. We're using our own identity on this web page to leave a comment as ourselves. So that's the demo. And if you pay close attention, you picked out the 2 separate features there. The first of these features is universal basic identity, and we can take the screen out of here for just a second. So you notice how we started out as a comet. We started out as a comet. And the underlying change that we made there to Eyre is saying, oh, every HTTP request that comes into us has an identity associated with it. And these are, naturally we pull these from the pool of comment identities because that address space is so large. Very important clarification to make right away. These are not real comments. We're not sitting here on the back end spinning up new comments, new comments as visitors, load our website. That's not what's happening here. All we're doing is saying, hey, this is an unauthenticated HTTP request. What we're going to do is we're going to mint a session with an associated cookie that we're going to give to the browser. And we're going to say, oh, we generate a pseudo-random comment name, and we're going to associate it with that session. The browser naturally is going to remember that cookie, and any subsequent request that comes in from that visitor will have that comment identity associated with it. So if there were multiple different blog posts on this website, I could go to each post, leave a little comment, and you could track my identity across those different replies. This is the thing where we say, okay, we're going to take the HTTP protocol and make it more Urbity. Previously, we only had an authenticated flag with incoming HTTP requests, telling the underlying application handling the requests whether that request was authenticated as ourselves or not. Just a binary yes or no. With this change, instead of looking at a simple flag, we say, oh, you're an application developer. You already know to look at the source.bol when your agent is being invoked. That's going to tell you which Urbit identity the current input or the current event originated from. We take that and we extend it to HTTP requests broadly. So whenever a request comes into Eyre and Eyre says, oh, I'm going to send this to this application, the application can now know an Urbit identity for the specific individual requester. Notably, you treat these fake comments in the same way that you treat normal comments. They're completely ephemeral. They may pop in and out of existence at any time. Anyone is free to create as many of them as they want. And so you really shouldn't be trusting them that much right away. This is behavior, and these are considerations that application developers should already be keeping in mind. And so now they no longer have to do special casing in the HTTP request case. It's just a very natural extension of the way the application model works already. Importantly, Eyre's channel functionality, which lets you poke applications or subscribe to them over HTTP, becomes available to these guest identities, as we call them. So previously, more dynamic user interfaces were primarily available only to like the owner of the ship, but now they're accessible to anyone on any public web page. The very obvious use case that comes to mind for this is a public chat stream for a group or a specific channel. Urbit.org used to have one of these. PelDev still hosts one of them. But before this change, doing so required re-implementing that dynamic, that reactive part in user space. Now you can just reuse the mechanism that already exists in Eyre in the exact same way that you're already doing for your private user interfaces as well. Other examples that come to mind, of course, are the blog comment case, where you have like comments on a blog or a visitor like guest book on a website, stuff like that. The second feature that you saw was cross-ship authentication, something we call eAuth in a callback to OAuth. If I can put my screen back on the stream here, the blog post we were looking at is the description of this feature that I initially wrote up when we were speccing it out. For both of these features, by the way, I'm going to make sure a link to the gist ends up in the comments and also in the video description, hopefully, so you'll be able to check that out and read that at your own leisure. So this eAuth proposal indeed has a whole authentication flow specced out, where the hoster ship and the sample ship do a little negotiation of like, oh, we're going to make sure that this unauthenticated HTTP client is actually, sample, like the ship identity we're trying to prove here. And so it does a whole song and dance, and there's interesting considerations and security implications there. And so I do want to walk through this in some detail. So this whole thing makes use of both the old school AIMS networking protocol and the new remote scry functionality. And with that in mind, you can split this login flow up into two parts. First, the visitor, like the visitor as in the web client, like visits a website provided by hoster and signals that they want to log in as a specific ship in order to initiate the login attempt. That's the first step. We use remote scry for that. Then the second step is that from the visitor's own ship, so sample in this case, we confirm that login attempt via AIMS, send that to hoster, and then have that like final confirmation of like, oh, this is actually you happen. The first part here is optional. We'll talk in a bit more detail about why that's optional a little bit later. So we start with step one naturally. we're on hoster.com, we're doing login, and we're saying we want to log in as sample. Hoster can't provide an HTTP response to that right away, because what it wants to do is redirect the visitor to their own ship so they can go to the confirmation page. But Hoster doesn't know where their own ship is. So to that end, it makes a scry request to sample. It asks sample, what is your public EAuth URL? This is something sample knows because its user has presumably logged into it at least once. So it knows what domain name, what HTTP endpoint it is accessible on. So it remembers that or figures it out somehow and returns that data in response to the scry request. Hoster receiving that data now knows the URL that it can redirect the visitor back to. It generates that redirect, but puts some additional information in the URL. Naturally, it puts its own name in there to signal which host ship is being targeted for the login attempt, and it includes a little nonce. This is optional, but it makes sure that when the visitor eventually returns to Hoster, Hoster can remember, oh, this was this specific attempt. I want to make sure they get brought back to the blog post about EAuth, for example, when they're done logging in. So the redirect goes back to the visitor's browser, and that follows the redirect to sample. Here, like in the demo, we assume that we're already logged in to sample. Very importantly, of course, that confirmation page you saw is not accessible if you're not already logged into sample. You don't want randos approving login to different locations. So then we get to the second step, where the visitor is on their own ship, on sample, and they're approving the login into Hoster. So here again, we specify, yes, we're trying to log into Hoster. They gave us this nonce, and we approve it. We do a similar song and dance here that we saw earlier, where sample cannot provide an HTTP response right away because it is unaware of where Hoster is actually, located domain name wise. Like it wants to return the user to Hoster, but it doesn't know where that is yet. Additionally, it needs to communicate some new information with Hoster to make sure that the attempt can be properly confirmed from the client side also. So it sends a formal aims message this time, not a scry, but an actual message to Hoster, which says, please open an EAuth session with this nonce and this secret token. The secret token is important because sample is giving it to the Hoster now, but it's also going to give it to the visitor so that the visitor can prove like, hey, I had authenticated access to sample, which because this was given to you via aims, and I also have it here. So these secrets are important for the confirmation at the end of the flow. So Hoster receives that information, remembers it, and then in response gives an, okay, we accepted the login attempt on this nonce. Now please return the user to this URL. You'll see here, hoster.com. Sample then crafts the redirect, returning to hoster.com, including the nonce, and importantly, the secret. The visitor's browser naturally follows the redirect, providing the secret to Hoster. Hoster looks at the request, verifies that secret against what it received over aims, and if those match, then it knows, oh, okay, the visitor is legitimate. They had authenticated access to sample. They were talking to it while I was talking to it. And so now we can create an Eyre session with a cookie that has the sample identity associated with it. Lastly, of course, we also have the nonce, and so maybe we remember what visitor was trying to do in the first place, and we put them right back where they started, but this time logged in. So that's the general flow here. This design of the protocol went through a couple of iterations before we settled on what we just went over. The way in which we use remote scry for the first part here is actually a very important change that prevents this from being a very, very trivial DOS vector. So an earlier implementation of this, instead of scrying out sample's public URL, would send an AIMS message asking like, hey, someone's trying to log in as you, please give me your public URL so that I can forward them. But you'll note that step 1 here is just an unauthenticated HTTP request. Any schmuck with a CPU and an internet connection can send that thing, and it would cause hoster to send an AIMS packet to whatever planet or other Urbit identity was specified in the login request. I hope you can see how that makes it pretty trivial to use a hoster or maybe even multiple ships to send traffic all over the network. Worse, I can target a hoster. Well, worse, they're both bad. They're both really bad. You can either say, I send a bunch of requests to hoster trying to log in as a billion different ships that aren't even booted yet. Hoster is trying to send AIMS traffic, which it needs to keep track of permanently to keep the guarantees that AIMS as a networking protocol tries to provide. But then it just, after a billion ships, it runs out of memory. It just chews into resources, and it has no way to clear that up. Similarly, I could use a whole bunch of public Urbit websites and have them all try to log into the same ship. So if I try to log into Sample from like 5,000 different hosts, Sample is going to get bombarded with traffic, and that's going to eat into its resources as well. Both of those are, very, very trivial D and DDoS vectors. Certainly not the kind of stuff you want to provide to the broader internet. And so that whole approach had to go. We could not be in a situation where unauthenticated HTTP requests could make Urbit ships send network traffic to each other. Instead, what we did is we said, okay, this entire first half, where we start on hoster and then get the data out, we do it with remote scry, and we make it entirely optional. So when we do it with remote scry, it's no longer a write operation on the network. It's a pure read. Yes, hoster is still going to need to track some state to be like, oh, yes, I know I started this login attempt for you. Like, I remember the nonce. I remember the redirect target. But that's all ephemeral state. Like, if you start it and don't do anything, we time it out after 5 minutes. And if you start so many of those attempts that we run into memory pressure, we can just throw them away. It's no big deal. If someone was actually in the middle of something, they'll just try again. The interesting thing that falls out of this is that the entire first half is optional. It becomes possible to not even know that hoster.com exists, but be on Sample and be like, oh, I know hoster wants me to do something with their web interface, but they didn't give me a URL, whatever. We're gonna completely, unprompted by any user-facing login flow. As a user, I'm going into my, ship's dashboard and saying, hey, I'm gonna make this request. Please log me into hoster with a nonce I just made up. Like, I approve of this. And then the entire flow just continues here from step 7 and onward. that's maybe not the first user experience of this that comes to mind, but it's certainly an interesting property, especially once you consider that you can kind of manage these things as like, oh, I, being sample, know that I'm logged into a bunch of these places. Well, I'm going to log these ones out and like log into someplace else and get redirected there for, an HTTP party I was invited to or whatever. The eauth stuff has some interesting additional use cases. It builds on top of the same approach that we talked about with the guest identities, where yes, every HTTP request has an identity associated with it. Now that identity may be actually your planet. And so that's still going to go into the source.bol, both for normal HTTP requests and the Eyre channel mechanism that you get access to again. So if you're in a private group on Hoster, you don't even need to like join that on your own ship for real. You can go onto Hoster's specialized web interface, log in as sample, and then view that content, because the underlying application just checks against, oh, what is your Urbit ID, right? Well, it's in the source.bol. I see its sample. I don't have to think about anything else. So again, a very natural extension of the way user space already works. Other use cases for this might be something I've been referring to as demo mode, where maybe you're in a text editing application and you want to collaborate on a document with me, but I don't want to install that application, or maybe I can't because I'm still behind on my Kelvin updates. So instead of using my own web interface, I can use yours and just authenticate as myself, and we can collaborate as we would expect. Certainly remote access is another important use case. The debug dashboard currently has a mechanism where you can configure a hard-coded, where you can configure a string as a password of sorts. And as long as you know the password, you can view the debug dashboard of someone else's ship. The alternative there is just having a whitelist of ships. And then if I tell you, please look at my debug dashboard, I add your ship to the whitelist, you log in with eauth, and then that's it. It just checks against that. Like, is the ship in the whitelist? So the universal basic identity, like the guest identity work, is already merged. It's definitely going into the Zeus 4.12 release, which is coming in, I don't know, actually a couple weeks, presumably. The eauth cross-ship authentication PR is still open. I'm still cleaning it up. As you saw, it all works. It's all there. It's mostly just minor cleanup tasks right now, making sure we have all the relevant tests in place. I'm not sure if that will be able to make it in time for Zeus 4.12. But if not that, then certainly the 4.11 release. So that concludes my overview of the new Eyre features that I implemented. I am definitely looking forward to making cool things with this. Also looking forward to seeing what you go and build with it. And yeah, that's it. I'm going to take a quick look in the comments here, see if there's any questions. And if you have any that you haven't sent them in right now. Try and cover them. Backwhiles asks, once I have loaded a JS front end as a guest, how might the JS know my pet P and the host pet P? So we do add a new endpoint to the to Eyre's like built-in interfaces. If I can briefly put my screen back on here, we'll see that a name endpoint exists, which simply returns the identity that we're already logged into. this endpoint already existed prior to this work, but it would always, because you could only log in as yourself, it would only ever give the host as the response. You definitely do still need to know the host identity, though, so there's an endpoint for that. This actually becomes especially important when you realize, or in the presence of a small detail that I did not talk about, which is that when you're authenticated as yourself, as the host ship, you can use Eyre channels to talk to any application on any ship. This isn't a feature that's made that much use of, but it's possible to, from your own web interface, like send a poke directly to someone else's ship without going through an application on your own. In the guest login, like non-local login situations, this is actually not the case. It's, like you cannot say, hey, I know you're a hoster, but I'm Sample and I'm trying to talk to PalDev. Hoster cannot send AIMS messages on your behalf, and so that doesn't work. So when you're logged in to someone else's ship, you can only talk to applications on that host ship. So the host endpoint becomes important, and then yes, again, name to see who you're currently logged in as. And so yeah, the JS can make simple calls to these endpoints to know that. John Hyde asks, if you want to expose multiple front ends from your ship, can you provide a different EOS open URL based on the nonce? Yes. So the way this is implemented is that if I'm on hoster.com and I start the EOS flow there, Hoster remembers that I started on hoster.com. And so it's going to, eventually tell Sample to bring me back there. But if I'm on buyacoolplanet.net, for example, and I still serve by Hoster, but I start the login flow there, it's going to bring me back to buyacoolplanet.net at the end of the flow. So it does keep track of those details, and of course also still the the specific URL. So maybe a blog post, maybe a purchase page, stuff like that. Next question by John Hyde is, what kind of breaking changes will this bring for user space def in 4.12 and possibly 4.11? So the only real breaking change, which is a bit of a soft breaking change, is coming in 4.12 with the guest identity work. It's it's not, I say soft breaking because it doesn't change types. It doesn't change types for any of the HTTP request stuff you might be dealing with, but it does change the behavior of the source.bol. And so where previously even for public web pages, you might have been asserting that the source.bol is the local identity, that's actually no longer going to be the case. So if you want to serve a public web page, you can't enforce that the source.bol is always the local identity. It's now going to reflect the identity, fake or not, of the HTTP client. So that's something to watch out for. Other than that, some of the Eyre types defined in LOL change. Very unlikely that you're referring to those directly, but if you are, then you'll know. Jack Fox asks, is there still a DOS-ish vector of churning out new comments? So sort of. Certainly I can keep creating new sessions on Hoster. I can, discard the cookies as soon as I get them, and Hoster will just, keep making new sessions for me. There is, actually, I might take a look right now and see, but it's certainly possible for Eyre to say, oh, whenever we whenever we get like a memory pressure notification, like, oh, we have so much state that we're starting to run out of memory, Eyre can just discard all the guest identity sessions and their associated channels and any other like semi, like mostly impermanent state that it wants to discard. Certainly all of that stuff is on the chopping block well before we start looking at, oh, we ourselves are logged in and have all these channels open and blah, blah, blah. That's going to be closed as a last resort, but we certainly look at the more ephemeral like guest identity stuff first. So that should protect it pretty well against like resource abuse situations. There's certainly room for more affordances here where you might be able to say, oh, I see this IP address has created 100 sessions in the last day. Maybe we should, put them on a ban list or like put a stop to that in some other way. There's a lot that's possible there. There's a lot that already was possible there, and we're doing almost none of it. Certainly, there's a lot of room there for improvement. Many, many things you can do to make that more safe. It hasn't been a priority because it hasn't been a problem. But as the network grows, and especially with features like this, as public web page utilization becomes a more prominent part of how people make use of Eyre, that's definitely stuff that's worth looking into more and spending more dev time on. So yes, there's answers there. We do the bare minimum to stay alive right now, and we might get more aggressive about that stuff in the future. All right. I think that's all the questions that have been posted so far. Don't see any new ones coming in, so we might call it here. Shorter stream to change the pace up a bit. Thank you all so much for coming, and I'll see you around the network, as always. Take care.